And now, are you able to listen? Hear
Of
my
course.
voice? Yes, right. So we will continue today the electrochemistry, the next part.
Okay.
In the previous class, we were discussing about the identification of electrochemical cell and the fabrication of electrochemical cell and how to identify or notate the cell. That is called cell notation based on the electrochemical series values. And electrochemical series is nothing but the list of electrode potential, that is reduction potential values, and how it increases or decreases, then how we should be able to identify whether the particular electrode undergo whether it is a reduction reaction or oxidation reaction naturally, and based on that how to identify the type of electrode, whether it is positive electrode or negative electrode, and from which we are able to establish the cell equation, also cell notation followed by cell equation. And we also know about the uh, what you call the Nernst equation for electro potential as well as electrochemical reaction also. Okay. So these are the things we have discussed in the previous class. And I was talking about this gas ion electrode and how it is established as what do you call this standard hydrogen electrode, and the value of electrode potential, that is the standard hydrogen electrode reduction potential, is zero. So above these potential values, SHE value, they are positive, electrode potential values are positive in the chemical cell series, and below that you've got negative potential. Okay. Then and based on that, we are able to, that is, establish the Nernst equations also for the electrode potential as well as for the electrochemical cell. Okay, right. Now, here is an example. Let me try to explain this. Represent the cell in which, take down, the following reaction takes place. The following reaction takes place. Magnesium as a solid reacts with silver plus ion, Ag plus, and its molarity is given, its concentration is given in terms of mole. That gives, so it is given as a 0.0001 molar solution. That is the concentration, right? That gives Mg2 plus with a concentration 0.130 m plus 2 Ag as solid. So what do you understand from this? They are given the cell reaction. Okay, please take down. They are given the cell reaction Mg Ag2 plus Ag plus 2 Ag plus gives Mg2 plus, then 2 Ag. Now you should be able to identify the redox reaction which undergoes oxidation Mg. Why? Because Mg gives Mg2 plus by releasing 2 electrons. So you can write down that equation. Mg gives Mg2 plus plus 2E. So this is the oxidation means anode. So this is the anodic reaction. So this should be placed at anode. So how to represent the anode? Mg bar Mg2 plus. Okay. So that should be represented on the left hand side of the cell notation. Is it not? So put Mg bar. First identify the cell notation. Mg bar Mg2 plus. Okay. Then followed by that, you have got the salt bridge indicated by double slash. So put double slash. And for the concentration, you can mention the relevant concentration of magnesium and the silver ion also. And the silver, what about silver? Ag plus becomes Ag means what? Reduction. So you can write down Ag plus E gives Ag. But two electrons are involved, so you can multiply by 2. So 2 Ag plus 2E gives 2 Ag. So that is the reduction reaction that takes place at which electrode? Cathode. So you can put at cathode. Now you, by combining these two reactions, you are able to get the cell reaction, and that is given in the problem itself. Okay. Now what is the question asked here? Calculate the E cell if E naught cell is 3.17 volt. So they are given the E naught cell value 3.17 volt. Okay. Now we can apply the Nernst equation. What is that Nernst equation? E cell is equal to E naught cell minus RT divided by NF. What is N? Wait a minute. RT NF into natural log. Okay. So natural log, and then product concentration divided by product of the product concentration of the product divided by product of the reactants concentration, reactants of concentration. So here the solid is taken as unity. So in that case, what is the ionic product available on the right hand side? Mg2 plus. So you can put Mg2 plus concentration divided by Ag plus concentration, but there are two Ag plus, so you must put square, remember. And in place of N, you can replace this by 2. Why? Because 2 electrons are involved, right? So you can replace by 2. And as we already discussed, the natural log should be converted into log to the base 10. So it is no doubt E cell. Pranav, are you following?
Yes,
Yes,
sir.
sir. Right. So E cell is equal to E naught cell minus 2.303 RT. So what is that 2.303? That is a factor to convert the natural log into log to the base 10. So you can put 2.3 now minus 2.303 RT divided by 2F, put 2F into natural log to the base 10. That is log log Mg2 plus concentration. That is the square bracket represents the concentration. So Mg2 plus divided by Ag plus then square. Okay. Now, what is the, you can substitute the values of R. Take down what is the R value? 8.314 joule per Kelvin per mole. Write down. R is equal to, you have to write everything. R is equal to 8.314 joule per Kelvin per mole. And T value, it is taken as the room temperature. So 25 degrees Celsius, that is equal to 298 Kelvin. Write down 298 Kelvin. Okay. And N here is 2. So we already put that 2. And what is the value of F? The value of F is equal to 96,487 coulombs. Okay, so write down 96,487 coulombs. So by substituting these values, you are able to get this 0.059. Okay, so now what you can further proceed? Take down 3.17. Don't put V, all these things as given in your book. You should not disturb the values along with the units. Okay, so units should be given separately. Okay, so put simply 3.17. Why 3.17? Because that is a voltage, that is E naught cell given. Standard cell EMF is given as 3.17. Okay, minus. Then you can introduce this value 0.059 divided by 2. Okay, how you get this 0.059? By substituting 2.303 into R into T divided by F. Okay, so that value gives this 0.059, and now we effectively utilize this into log of, don't add this V, all these things. So I'll remove all this V. Log of, now what is the concentration of Mg2 plus? That is given as 0.130. So you can put 0.130 divided by, and what about this? This is nothing but 10 power minus 4, is it not? What is that? 10 power minus 4. Why? Because it is 0.0001. It means 10 power minus 4. So you can put 10 power minus 4 instead of writing 0.0001. You can write simply 10 power minus 4 whole square. Why whole square? Because Ag plus whole square. Okay. So when you bring this 10 power minus 4 whole square, and A power m whole power n is equal to A power mn. So based on, you can explain all those things for better understanding. So 10 power 8. So the denominator becomes 10 power minus 8, right? So 10 power minus 8, when it goes to the numerator, it becomes plus 8. So 10 power plus 8 you can put. Okay. Now 3.17, write down 3.17 minus, and you can roughly say zero point zero 0.06, roughly zero point zero 0.06 divided by 2. Okay. Divided by 2. That is zero point zero 0.03. Okay. Into log of 0.13, write down 0.13 into 10 power, what is that? Plus 8. Okay, 10 power plus 8. And make it as a scientific notation. Can I write down the scientific notation for zero point 0.3, 0.13 into 10 power 8, which is nothing but 1.3. Okay, again, right, again. So 3.17 minus 0.03 into log of 1.3 into 10 power 7. That is already minus 1, this age. So 7. You can safely put 7 into 10 power 7. Okay. Now you have to find out the log of, listen to me, find out the log of 1.3 into 10 power 7. How to find out the log of 1.7, 1.3 into 10 power 7? For find out the log for 1.3. Okay. And the 10 power 7, that is taken as 7.0. So write down 7.0 plus your log value. What is that? 1139. So write down 1139. 1139. So 7.1139. 7.1139. Okay. Into, sorry, 7.1139. That is the logarithm. You have to take that logarithmic value as such. Okay. Now, no, wait a minute. Now, you can proceed further. 3.17 minus, are you following? 3.17 minus 0.03 into this 7.1139. So multiply this. If you want to make it as a single digit decimal, you can make it. Okay. And get me the value. What is the second term? First term is 3.17. Second term, wait first. 0.21. Okay. So 0.21. So the second term is a 0.21. Now you have to subtract from 3.17. Therefore, 3.17 minus a 0.21 is nothing but 2.96. Okay. Has anyone written this neatly so that I can display here? Bring it to me. Come quick. Anyone? Anyone? Nobody. What is the use? See here, we have got the cell representation. Okay, right? And MG, you have to mention the concentration here. Mention the concentration here and put yes. Do you follow? I'm correcting yours. You have to follow. Then yes. So you have to put all these things and put the concentration values and write down the concentration. Whenever you solve any problems, you must put given. Given. What are given? So the reaction is given. You can write this and the values are given. What are those values? That is Ag plus, you have to mention like this, Ag plus concentration is equal to 0.0001 m. That is nothing but 10 power minus 4 m. You have to mention like this. And Mg2 plus. So what is the concentration of Mg2 plus given? So that is 0.13 molar concentration. Okay, so now you are introducing, you must mention, I have applied Nernst equation. So Nernst equation, according to Nernst equation. Okay, and this is the basic Nernst equation. And what is this? This is product concentration divided by reactant concentration. Okay, you have to write down the product and reactant. Mg2 plus this one. Okay. And by converting into uh, log to the base 10, you are introducing 2.303, okay, to F. Okay, so N is equal to 2. How do you find out this N? And where is this electrochemical reaction? Where is the electrode reaction? You are not shown that. So here you must write legibly. Okay, so the N is found to be 2 from the electrochemical reaction. And this is wrong. Joule per Kelvin per mole and 298 Kelvin. This is Coulomb capital letter. And E cell, okay, E naught cell. What is this? So 2.303, 3.1706 log. And what is this? Why you have not put this 0.13? Who will put? Huh? 0.13 into 10 power 8, 1.3 into 10 power minus 7. And we are introducing the logarithm. Okay, so where is the log value? So 1.3 into 10 power 7. So 7.11. You have to find out like this log of 1.3 into 10 power 7. So 7 point. What is that? 21347, etc. You have taken only 7.1139. 39. So 1139 and 27. So finally, and you are skipped immediately. So 3.17 minus 0.21. So that is equal to 2.96. And finally, you have to reproduce. That is the E cell. It's not E naught cell. E naught cell is this one. So E cell is 2.96 volt. So this is the answer. So likewise, you have to present. Okay.